In this video, we're going to be talking about the relationship between face coloring and flows on graphs. And the best way to see the relationship is just to do a couple of examples. So let's start here. Construct a nowhere 04 flow on G by coloring its faces, then assigning the corresponding foreflow. Now, note that we want to do a face coloring, and to do a face coloring, you need an embedding. So for our purposes, we're just going to be thinking about planar embeddings, but this same process works anytime you have what's called a two-cell embedding on any surface. Okay, but we're just going to be thinking about planar ones. Okay, so here we've got our planar graph G. So this says we want to get a foreflow by coloring its faces, then assigning the corresponding foreflow. Okay, so we're going to talk about what this means, the corresponding foreflow. So first, let's color the faces. So maybe we color the outside face 1, and we give this one a 2. That means this one can't have 1 or 2, this one can't have 1 or 2, so maybe we both give both of these 3s, and then this one can be a 2, right? So this is a face coloring. Okay, and once you have your face coloring, we want to talk about how you create a foreflow based off of this. And by the way, it's 4 because we can always color the faces of a planar graph using just 4 colors. Okay, so let's see what happens. So first, how are we going to make the direction on each edge, right? So a flow consists of 2 pieces of information for every edge, right? The direction and then an edge weight. So first, let's figure out what the direction should be. Well, when you're assigning these directions, we want to orient the edge so that the smaller face is always on the right of the edge. Okay, so for example, this edge will be oriented this way, because if you're traveling along this edge, right, in this direction, you can imagine walking along this line, and on your right-hand side will be a 1, and on your left-hand side will be a 3. Okay, so that's why we made it this direction. We want the small side to be on the right-hand side. Okay, and similarly here, we'll orient this left, right, because if we're walking this way, then on our right-hand side is a 1, and on our left-hand side is a 2. This one will be down, right, so that on our right, if we're moving down, our right-hand side is this, which is the 1, the infinite face, and our left-hand side will be 2. And similarly, so you notice I started with my smallest number on the infinite face, and that means that everything on the outside is going to be the same orientation, right? It's just going to go in a big circle because I specifically put the smallest number on the outside, which means that it'll always be the one on the right, so you can just sort of choose an orientation and go around. Okay, so now let's look at these interior edges. So maybe this one, for example. So you might ask yourself whether this is going to be going left or right. And it will be going left because if you're moving along this way, then your right-hand side would be a 2, and on your left-hand side would be a 3. Similarly, this one will go up, putting the 2 on your right and the 3 on your left. And this one will go sort of down, right? No, it will go up. Right, putting the 2 on your right and the 3 on your left, and this one will go down, right, putting the 2 on the right. If you're moving down, right, your right-hand side would be this side, putting the 2 on your right and the 3 on your left. Okay, so this is how you get all the orientation of the edges, right? You orient the edge so that the smaller face, smaller color face is on the right, and I'm going to put right in quotation marks because it may not necessarily be your right like you're looking at the screen on your right, but on your right as if you were walking along in that direction. Okay, so let's just transfer all these over, and then we'll talk about what edge weights are going to go on here. Okay, and then the weights you want to put on here are going to be the difference between the 2 faces. So, and you want the absolute value of the difference between these 2 faces. So you're never going to end up with negative numbers using this method. So here you've got a 3 and a 1, the difference is 2. Here you've got a 2 and a 1, the difference is 1. Again, a 2 and a 1, the difference is 1. Here the difference is, so 2 and a 3, the difference is 1. 3 and a 1, the difference is 2, right? 3 and 2, the difference is 1, 2 and 1, the difference is 1, 2 and 3, the difference is 1, here the difference is 1, and then that should be everything. So let's just double check that this actually works. So here, 1 in, 1 out, check. Here, 1, 2 in, 2 out, check. 2 in, 1, 2 out, check. 1 in, 2 in, 1 out, 2 out, check. And this one, 1 in, 2 out, check. 2 in, 1, 2 out, check. Okay, so this works, right? And in fact, it's always going to work. And you know it's going to be a nowhere zero flow, because how do you get these weights? You take the difference between the two colors on the faces. And the only way you would get zero is if those two faces were colored the same, which would not make it a proper face coloring, right? So as long as you do actually have a proper face coloring, none of these weights are going to get zeros. And then you know it's going to be a 4 flow because the largest number that you're ever going to use is a 4, right? But you're always going to be taking the difference. So like the biggest difference it could possibly be is your smallest number 1 and your largest number 4, whose difference will be 3, which means yes, you'll always get a 4 flow if you're dealing with a planar graph. Okay, so let's do this one more time. Assign a 4 flow to the following graph. Okay, now, first thing to notice here is that this is not a planar embedding. This is a planar graph, but it is not a planar embedding. So you see, we don't have clearly defined faces here, right? I mean, like if you consider this isn't really a face. It's sort of an artificial face because this isn't a vertex. It's just edges crossing. Really, there's like this underlying face here of this large 4 cycle, but even that's not quite right because you have to have an embedding to talk about faces. So step number 1 in this is to get a planar embedding of this graph. Okay, so we can see here's a crossing and here's a crossing. So what we're going to do, so remember this is isomorphism, we're just going to sort of slide this vertex over so that it sits inside this face, and that's going to eliminate both of these crossings. So essentially what we'll have here so that's this piece of the graph. And then I'm going to ignore this vertex and these 3 edges and draw in the other pieces really quickly. So then I've got this. Right, so that's everything except this vertex and its associated edges. And so now we're just going to sort of shift this over here. Right, so that's on the inside here. We're sort of sliding it along. So these graphs are isomorphic. And now that we have an embedding, we can start our process, which we started with last time, which is we need to get a face coloring of this graph. Okay, so again, I recommend that you always start with the smallest color on the outside, 1. Or if you want to think like a computer, your smallest color could be 0, and you could use the numbers 0, 1, 2, and 3. That's also fine. I'll just start with 1. And then, so for example, this needs to be a 2. This can't be a 1 or a 2, so we'll give it a 3. This can be 1, right? Because remember, you want to sort of reuse the lowest number that you can at any given stage. Okay, so then this one can't be 1, but it can be 2, right? And this one can't be 1 or 2, but it can be 3. Okay, so here's our face coloring, and now we want to use this face coloring to create a flow on the graph. Okay, so here's our graph. So maybe I'll just remind us, well, okay, maybe we'll just scroll up and down. Okay, so again, we put the smallest number on the outside, so all these outside edges, they're going to be oriented in a big circle, right? Because the smallest number is always going to be on the right, which means these need to be moving in this direction. So like this is a 2 and this is a 1, this is a 3 and this is a 1, right? And by choosing that smallest one on the outside, all of these are going to be like this, putting the outside face on the right, right? So it's going to be a big cycle around here. Okay, so now we need to think about all these interior edges. Okay, so first this one, we've got 2 and 3, so this needs to be oriented down to put the 2 on the right-hand side. Then we've got, this is a 1 and this is a 2, so both of these need to be going this way to put the 1 on the right-hand side of these edges and the 2 on the left-hand side. Then this is a 3 and this is a 1, so this one will go like this. Okay, and then this is a 2 and this is a 1, so this one will also go this way, and this one will go this way, putting the 2 on the right and the 3 on the left. Okay, so here are our orientations. And then we assign weights just by taking the difference, right? So the difference between 2 and 1 will be 1. The difference between 3 and 1 will be 2. The difference between 3 and 2 will be 1. The difference between 2 and 1 will be 1. The difference between 3 and 1 will be 2. Right, and you always want the absolute value. You don't want to sort of, you never want to subtract like 1 minus 3. I mean, you can do it that way, but really we always want the positive difference. Okay, so then this was a 1 and this was a 2, so both of these will be 1s. And then 2 and 3, so this difference is 1. These are both 2, and this is a 1. Okay, so you can go back and double check that that's going to work. And let's just sort of run through and make sure that this actually is a flow, right? 2 in, 2 out, so this one's fine. 2 in, 2 out, 1 in, 1 out, so this one's fine. 2 in, 1, 2 out, this one works. 1, 2, 3 in, 1, 2, 3 out, this one works. 2 in, 2 out, 1, 2 in, 2 out, 1 in, 1 out. Right, so this does give you a flow. And right, in fact, this is a nowhere 0, 3 flow, right? Because you want to take the largest edge weight and add 1, and that's the number that goes here. Now it asked us for a 4 flow, but this is totally fine, right? Remember, because a 3 flow implies a 4 flow, and it implies a K flow for any K larger than 3. So anytime you have a planar graph, it's really easy to determine a flow because it's essentially just do a face coloring, which is very simple. And once you have that face coloring, you can use this coloring to uniquely determine, so like this is the one single flow, right, that corresponds to all of this, right, using the method that we talked about. So this is a sort of nice step-by-step process to create flows on graphs if they are planar, right? Because if they're planar, you can make a planar embedding. From that embedding, you can color the faces, and then once you have all the faces colored, you can use that to figure out the direction and the edge weight for every edge.